Hello, everybody. My name is Jess Holbrook. I'm one of the leads of the People Plus AI research group at Google. And I'm excited today to get to talk to you about our team's vision and some progress we've made on a more human-centered approach to AI. What I'm hoping you leave with today is a way to think about a more human-centered approach to AI, along with examples and some practical next steps that you can start using in your daily work immediately. So to kind of start us off, this is probably not news or that wild of information to this group, but machine learning has really kind of taken a lot of the product world and research world by storm over the past few years, and has been able to have breakthroughs in numerous prediction and inference tasks across many different products. These include things that we experience in everyday life, like song or video recommendations. They've been really useful in predicting future events based on past events, like how much an airplane ticket might be, although this particular example hasn't aged very well in the past 6 months. They're being used to do more rapid language generation and doing things like smart reply for YouTube creators so they can engage with their audiences more easily. And ML has enabled some really interesting accessibility cases that were previously really just impossible to do. So here's an example of using computer vision to read the labels of goods in the grocery store and relay that information in a more accessible way to the user, all happening on device, nothing going to the cloud. And then we're also seeing the application of machine learning and AI in much more higher stakes domains. So the really obvious one that people talk about a lot are self-driving cars. But then it's also being deployed against some of the biggest challenges the world faces. So this is an example of some really exciting work recently announced using ML and physics models to do better flood forecasting around the world, which should give people in those regions much more time to react and will quite literally save lives. And so when we look at how machine learning and AI are talked about, and thought about, it's usually from a very technical angle, a very mathematical and statistical framing for everything. But one of the things that I think is really important for us to understand is that human perception drives virtually every facet of artificial intelligence and machine learning. Just for the rest of the talk, I'm going to use those two terms interchangeably. So if we take this extremely condensed version of how most machine learning works, we have training data that are collected and labeled, models are built and trained and evaluated, and predictions are generated. I'm really just focusing on supervised learning here for simplicity's sake. And it seems like it's very about data, about finding relationships, and about serving up those inferences or predictions. But when we look at it, it's really obvious that the human angle is incredibly prevalent in all of these. So first, we choose the data sources that we use for training data and how they're labeled. We determine the evaluation metrics, the loss function and reward function optimizations for any kind of model, and we decide when it's ready or done or good enough. And then we all get affected by the results of these predictions. So there's not, it's not an open loop, it's a closed loop system of like when we actually see a recommended song and listen to it or click on it or like it, that gets fed back into the model and that affects us and that affects future model performance. And so we really need to recognize this human element in the entire, not just output of machine learning and AI systems and not just interaction, but the entire development process. And that was one of the founding, I guess, realizations that led to the group that myself and Fernando Villegas and Martin Wantenberg founded, called the People Plus AI Research Group. So our mission is to do human-centered research and design to make People Plus AI partnerships productive, enjoyable, and fair. If you want to learn more about our work, there's the website. All of our stuff is up there. So PAIR does three big things, and we do them in an effort to more holistically try to bring a human-centered approach to AI. So first, we conduct and we publish human-AI interaction research. So this usually shows up in academic journals, and we're really looking at every different role and type of person who interacts with machine learning or AI. So at the top is an example of part of our work around Bertology, or looking at some of the language models and how they represent language within them. And on the bottom we have, which is strictly for developers, of course. And at the bottom we have what we call our People Plus AI Guidebook. So this is a whole set of tips, tricks, best practices, frameworks for UX professionals and product managers to follow when developing AI. And we're going to get into a lot more of that in a little bit. Second, we create and launch open source tools and platforms to build AI responsibly. So it's not just enough for us to say people should do things or point out that one group is doing something wrong. We really try to build the tools that allow people to build AI and ML in a responsible way. So at the top, we have an example from a tool we just launched very recently. We haven't made too much noise about it yet, called the Language Interpretability Tool. That's really trying to help ML developers using these new language models and incredibly powerful language models understand exactly why the model is making the predictions and generating the text that it is making. And third, we do our best to widen the circle of who can participate in the development and application of AI. So this can come in many different forms, but it comes from a central belief that we think that machine learning and AI in the development process need to be more participatory in nature. And to do that, we need to create lots of different interfaces for different people to be able to participate. So at the top is one of the more famous ones. It's something called Teachable Machine, and it was built on top of a platform that our team built called TensorFlow.js, which allows people to train a model in their browser, all on their machine, just using their webcam. And it's a really fun way to get to learn about how AI and ML work. And at the bottom is a screenshot from our new Medium channel, where we're publishing conversations about AI and ML from many different perspectives that range from case studies within Google to perspectives from people thinking about how AI and society are interacting outside of Google. And then just some fun stuff like what Pear is reading to kind of give an idea of where we're focusing these days. So one of the things I mentioned was this thing that we call the People Plus AI Guidebook. This is something that we launched back in May of 2019. And it's a fairly substantial resource with 6 different chapters in it that really tries to walk people from the beginning to the end in a way that they can really practice a human-centered approach to AI. And for the rest of the talk, I actually want to get really, really concrete with some ways that anyone developing AI can start to take a more human-centered focus today coming from the guidebook. So like I mentioned, the guidebook has these 6 chapters: user needs and defining success, data collection and evaluation, explainability and trust, errors and failing gracefully, mental models, and feedback and control. This first example is going to focus on user needs and defining success. So one of the core challenges we see in the AI and ML space right now is people are just asking, can we use AI to blank? Can we use ML to blank? And they're really just hopping toward a solution, and always an AI or an ML one, before really looking at the original problem and if it's best served by AI or ML. As anyone who's ever developed AI or ML knows, it's not a cheap and easy process. It's not simple. It's very complicated. It's very time intensive, even with lots of services and technologies like AutoML that are coming along and making it easier for people. What we're trying to get people to think about instead is answering the question, how might we solve blank? What is the user need or business goal you're trying to achieve? And then can AI solve this problem in a unique way? Is it worth it? Is it worth the trade-offs that you're going to have? One of the ways that we do this is a simple 2x2. If you work on anything long enough, it just becomes a 2x2. So if you have a lot of different ideas for a different feature or product or service or whatever it might be, we like to just have either an individual or a whole team put them along the axes of this 2x2. So on one side, you have user impact. Do we think it'll make a big difference in people's lives or a little difference? And then on the other is just, is ML needed to do this thing? Is it required or not? And things in the upper right-hand corner that have large impact and are only enabled through machine learning are the things that we'll typically target first. The trick I always tell people too is the thing we target second is typically the stuff in the left upper quadrant, which is high user impact, but no ML needed. Again, going back to that, you don't ML if you don't have to. And even in that example, even in that description I just gave, sometimes the most impactful thing is the non-ML thing, and so we'll do that. We're also trying to help people think about, and it's really important for you to think about, is AI a good fit for the problem? Because it's not always the best option. There's been a lot of hype in the past few years, and it seems like anything, any problem you have will be better served by AI than not, but that's not really the truth. So AI is going to be a lot better at things like personalization or anomaly detection, or the prediction of future events based on historical ones, and things like natural language understanding. But I want to highlight some of the places where, and there's a lot longer list there, of course, but like I want to highlight some of the places where AI is probably not better. So one where the whole industry struggled is really when there's very costly errors. So every kind of inference or prediction has some kind of confidence associated with it, and none of them are at 100%. So if there are very costly errors, even if they're very low likelihood, relying solely on AI or an ML is probably not going to be your best option. Another one is if extreme transparency or clarity of why everything in the system happened the way it did is required. So there's sometimes government regulations, and sometimes, again, there's just a need to know if anything goes wrong, exactly what happened. At this moment, you're not going to have that level of transparency. You probably never will, though there's a lot of strides being made. There's a lot of talk about the black box of AI, but there's many different efforts and tools coming online very rapidly that are starting to shine a light into that box. But we're probably never going to get to 100% transparency. The third is if you really need extreme predictability. I mean, this is kind of the trade-off with personalization, right? Personalization makes things more tailored to somebody or a group, but it also makes them less predictable. It's moving things around, it's changing content. So if extreme predictability is what you need, AI is probably not better. And an example of this is, the brake pedal in a car. It's really good that the brake pedal in a car is very predictable and isn't being personalized or moved around or adapting to what you're doing. You want that to be predictable every single time. And then one of my personal favorites is that AI is better. People tell you they don't want AI or ML used in it. We seem to forget this a lot, but there's been, frankly, a lot of very warranted backlash to a lot of AI and ML applications and algorithms that are used in various decision-making processes, especially when it comes to things like allocating civic resources. So if people don't tell you they want it, you're probably better off not actually using it in the solution. So from there, I want to move on of, we like to look at it if you've identified some user needs or you've identified your definition of success for what you want to build, then you really look at the data collection and evaluation. I'm sure everyone at this conference knows that data is, the core of any kind of ML system, and is really going to make or break just about anything you try to accomplish with it. So one of the big challenges that we've been trying to have people embrace is really translating user needs into data. And so asking a few big kind of questions like, does our training set have the features and breadth to ensure our AI meets our users' needs? Should we, which sounds simpler than it is, that's really tempting to cut corners. One of the easiest ways to cut corners is, number two here, should we use an existing training data set or develop our own? Almost always people will choose to use a training data set or one that already exists if they can help it, because it's so costly often to collect their own, although that really tends to shift how appropriate the data is to the use case they're trying to solve or address. And third, how can we ensure that raters aren't injecting error bias, or we as the product developers aren't injecting error bias into data sets when generating labels or when creating data sets? And so, I know that this group knows about data and thinks about data, but just again, some various examples here. So data for a model can be things like annotated text. So we have this sentence here, along with the parts of speech that each word represents, labeling those up. There's a way to feed data into a model. Lots of them use some form of interaction log. So using historical data to detect, future events like security breaches or anomalies. Good old-fashioned labeled data for supervised learning. So labeling, things a cat, not a cat, especially for the most simple binary classifier, is kind of one of the oldest, or most, I shouldn't say oldest, but most used examples out there. And maybe for a little bit more fun one, it's kind of interesting, you can also go from images to audio. This is an example that we had with the NOAA trying to label and then build a model to detect and and whale songs from across the ocean. So you can kind of go from interaction logs, text, images, audio, whatever it might be. But regardless of what the data is, a really important role in data collection is how the training data are sourced and how those data are labeled will directly determine the AI system output and the UX quality. These are inescapable, and a lot of times they're decoupled in the process, and we kind of think about the UX implications of the data we collect way down the road. And this leads to all kinds of problems in product market misfit. So aligning user needs with training data needs is really what we're trying to do here. And one of the ways that these really become separated is when you make a lot of assumptions about your data or how your data will match your use case. And so I want to give an example. So usually presenting this in front of a group of people, we have a pause and I ask everyone to imagine a shoe. So everyone, wherever you are, I'd like you to take a moment and just imagine a shoe. All right, one drink of water. Hopefully everyone has something in mind. This will also be fun too, because this is usually the raise your hand part of the talk. So you'll know if this is you or not. How many of you imagined a shoe like this? Something like a sneaker, something casual? I'm imagining hands going up across the world. How many of you imagined something like this? Something more like a business shoe or a loafer? Right? And how many of you imagined something like this? A high heel, traditionally worn by women. All right. So usually what we have across, whenever we ask people that, the majority of people think of a sneaker or something like that, then the dress shoe traditionally worn by men, and then the high heel. And this is a great example of something that seems really kind of basic, like imagine the shoe or tell me if this is a shoe or not, can lead to bias in models and can unintentionally inject bias into models where they might be biased toward the sneaker versus the high heel. Another example of this is a fun experiment that the Creative Lab at Google did a while back called Quickdraw. So they created a website and people would go to it and you would try to draw a picture and the AI model would try to guess what it was. And one of these were shoes. So people were drawing shoes, but everyone was drawing the sneaker. And so what happened is the image recognition model that they were using started to become biased, and it wasn't recognizing the loafers or the high heels nearly as soon or as accurately as it were the sneakers. And so the team had to go and intervene with the model to actually balance out those accuracy rates. And so this is another great example of you can think kind of everything's working, especially in the beginning, because you're having this good accuracy in this model, but really there's some hidden bias lurking that you need to continually look out for and intervene with if it shows up. Another example of this is with the Quickdraw data set as well, which is really interesting, as a chair. And so as we look across, we can see, it's interesting to call it bias, but I think this illustrates the point. You can see bias across countries. So they were all asked to draw a chair, and here's an example where we pulled, I think it's like 100 or 1,000 or something examples of each of these, and you can see how different countries have slightly different views of what a chair looks like. The one that really stands out is the angle with the Korean chair, right? It's kind of tilted off to the side where like Brazil and the United States are kind of facing forward, or you're getting that silhouette of the back on the left. Whereas South Africa, they're almost all facing forward. And so even as something as simple as draw me a chair, draw me a stick figure chair, you can start to see these biases or tendencies or different unexpected relationships in the data start to appear. A more serious example is something that used to happen with Google Translate. So Google Translate would do translations in some languages, have a gender-specific language. And so, well, Google Translate was very focused on, getting you a translation as quickly as you can. These are people use these in the moment and need good translations quickly. And so they would give the top result. But one of the outputs, one of the consequences of that is that it would oftentimes give back a gendered result, like he is a doctor, not he or she is a doctor, or something like that, because it was the most represented in the training data set. And so the team intervened and started to provide translations that are gender specific. So if somebody made a translation from a language that didn't have gender specific markers to one that did, they wouldn't be reinforcing that bias, and they would give both potential options then. So I've talked a lot about the different kinds of bias that can affect the data, or the data that can show, the bias that can show up in the data and affect your model output. And so what can you do to help avoid creating a reinforcing unfair bias? So most of this fundamentally starts with the kind of team that you have. And you have a diverse set of individuals working on your team who are frankly just going to spot this stuff way before you do because they have a different lived experience than you. This happens all the time where we may think we may have to spend some elaborate amount of time and money to do research to discover something that if we had just had a different kind of team makeup, they would have pointed out and said, you know that this is a problem, right? You can save yourself a lot of money that way and time. Another way you can do it is really to think about the label tasks that you're having somebody do. So if you're creating your own data set, you have to ask the labelers to label data in a certain way. And the way that you design those matters a lot. And I love to highlight this because in the world of UX and product development, like we don't think about designing labeler tasks, but they're going to be the things that are really going to be at the core of the model performance and eventually the user experience. So I'd like to show this example here. So this is the shot of Google Label Rating Center. And it's filled with people who are raters or labelers who label the data used to train machine learning algorithms, most frequently in supervised learning or semi-supervised learning models of some kind. And they look through all these different kinds of tasks and label them with some kind of thing. So this is one of my other favorite things is to look through the UIs of these tasks, which are just kind of amazing. So one is really looking at comparing the information on two different sites and trying to figure out, the right kind of information that you want to be represented when doing a Google flight search. This is another one I really like. So this is about hairstyles. So they're shown a picture and they're trying to select from this group of which hairstyle represents this person. Even if you look at this, think about this and how this might represent the different kinds of hairstyles that are represented all across the world, right? This is still just a tiny little fraction. And then you also have these kind of interesting phrasings that these people have used, like coily hair versus wavy hair. All of this is going to start to affect the kind of data that you have in the quality and how the model and in turn the product is going to perform with the different people who look or are represented by these different classifications. And this is one of the things I love too, is that it can seem like the most simple labeling tasks can become very complex and have a lot of questions embedded in them that you don't realize. So if I just say, please select all the images that show a cat, on the left you have a cat, but the cat even has eyes of two different colors. That's pretty easy. Okay, that's a dog. I'm not going to select that. But then you might get to something like an illustration of a cat popsicle or a cat statue or a tiger. Like, did those count or not? And the specificity and the way that you design your task really has to do with, well, how are you going to use this? What is the cat model, if you will, supposed to detect? Is it just domesticated cats? Is it a representation of a cat in any way? Or is it anything in the feline family? Those will have you create very different labeler and rater tasks. That's just talking about cats. Then you get into aspects of please select all the images that show a woman. So even more complexity comes in here, and it makes us really question how we think of these concepts and how binary they are, because you're basically setting up a binary task. It is or it isn't. There's a whole other area we can get into there about how you can set up tasks to not be binary. But then you also get into the real problem of a lack of coherence between a lot of internal states and external expression. So this shows up with concepts like gender. One of the most frequent ways that it shows up, though, is with affective computing. So when trying to do something like emotion detection, there is a big difference between the experienced, expressed, and perceived aspects of emotion. So we experience an emotion, we do some kind of expression, typically with our face or with our body, and then it is perceived as by another person. Those are three separate things. And to ask people to label those, especially to label a personal experience, is quite literally impossible. They cannot do it. The best somebody can do is label the expression of something, and not even really that. All they can label is their perception of that expression. So this becomes very complicated very quickly. And a lot of this gets down to how are you going to label this data? I mean, again, I'll go back even a step further. Should you be doing this in the first place? Maybe not. Maybe you should be doing it with some kind of other system. If you determine that you are, then it really does come down to how are you designing these tasks to really embrace and represent the construct that you think you are. This is just kind of restating what I said. Hopefully I've impressed on you that the training data and how the data are labeled will directly determine the AI system output and the UX quality. And I really advocate for you to spend a lot of time thinking about the data set you're using, how it maps to the use case and to the context you're trying to represent, and then spend a labeler task to make you're going to get data labeled in the way that you really want it to be. So the third and the final chapter and example I want to talk about is from our Explainability and Trust chapter in the guidebook. And this is really around a concept called Calibrating Trust. So it's very important to calibrate user trust, and I'll talk about what that means. And then to think carefully about transparency and explainability, and how much can you explain to a user and what is actually most useful to explain and not. And then really thinking about how to display the confidence associated with a different AI prediction to your user. So this is a vastly simplified, we're fans of the vastly simplified diagram around here. So imagine we have a spectrum of trust from absolutely no trust in a system to way too much trust in a system. So no trust is, I don't think it can do things that it can, and I actually lose out a lot of benefits. And the too much trust is, I overtrust it and trust it with things that I really shouldn't do, like maybe like a fully self-driving car, fully self-driving software or something. Calibrated trust is where we want to be. I know what the system can do well. I know what the product or feature can do well. And I know when I need to use my own intelligence to correct the system. And so we're always aiming for that. This is one of our favorite examples of this. You don't want to get to the place where your expectation is something amazing, but reality is leaving you wanting just a little bit. So the basics of calibrating trust are really thinking about the stakes. So what are the risks of under or over trusting the system? And you're probably going to want to actually set it up to be biased one way or the other. It's really, really hard to hit that kind of perfect in the middle. What system data are impacting trust in this situation? What user knowledge is impacting trust in this situation? So this comes down to good old-fashioned UX research, or the very simple version is talk to people who either use your product or you think might use your product, and really understand where they trust it, what they think it can do, what they think it can't, and why. And getting in, and then try to figure out ways, either through the user experience, the UI, or writing, that you can explain more clearly what the product can do and what it can't do so they can calibrate their trust. After that, you're really going to need to figure out the related explainability needs. So explaining why a model made an inference it did is a huge part of helping people calibrate their trust and build the right mental model. This is another 2x2. Again, we always get back to a 2x2, where there's kind of some suggestions where on the vertical axis, we have confidence of the system in its prediction from low to high. And on the left, we have user impact, or sorry, left to right, we have user impact going from low on the left to high on the right. I'm gonna actually kind of skip this here, but maybe I'll pick one where if you have user impact that's high, but system confidence is low, users should always verify the system's decision. You want to consider things like giving an explicit explanation of why a different inference was made, displaying some kind of uncertainty, and giving a very complete explanation. That's not the case in every example. Whereas you might have something, actually I'll use the kitty corner example, when confidence system is very high and user impact is very low. So users should trust the system's decision with minimal explanation and consider using an implicit explanation or no explanation. A great example I think of there is like spam filtering. Almost all spam filtering uses some kind of machine learning right now, but it doesn't really make a lot of sense for a spam filtering system to say, pop you a notification to say, hey, I stopped some spam and here's why, kind of defeating the purpose. You can visualize the confidence in an inference or a prediction in many different ways that really range from things like categorical, so you kind of show the best match. Think of these as maybe like different song examples versus good matches or low matches, and best, where again, you're kind of highlighting whatever you have the most confidence in, but also giving some examples that didn't, you had lower confidence. You can always use numeric, but we've actually found that that's not very useful in most cases. that really reserves itself for places where somebody would actually make a different decision if a model inference was, say, 90% versus 85% confident, and that really has to do with your use case. And then there's various data visualizations you can do as well. All right, so those were the 3 big examples from the guidebook. I'm hoping that those gave you some really concrete new ways to think about building AI and ML models into products. There's 3 others there. There's tons of information at pair.withgoogle.com. You know, I hope you also kind of come back to our central thesis or insight or whatever you want to call it, and that remember that while a lot of this seems to be about data, computer science, sometimes very obtuse mathematics, there's an extremely embedded human aspect to all of this. You know, we choose these data sources, we determine the evaluation metrics a model is going to perform against, and we get affected by the results. And we have to acknowledge this and embrace this. So I really hope you join us, and let's make a human-centered approach to AI the default. Thank you very much.